Good morning everyone. I am R. Shakila Devi, Assistant Professor, Department of Computer Science Engineering from Rohini College of Engineering and Technology. In today's video, we are going to learn Unit 1 Deep Neural Networks from the subject AD3501 Deep Learning. So let's begin the basic idea of what is a deep neural network is. A deep neural network or DNN is a machine learning model inspired by how the human brain works. It contains multiple layers of artificial neurons. Each neuron receives input, process them, and process the signals forward. So every connection has a weight. A positive weight increases or excites the signal. The negative weight reduces or suppresses the signal. So DNN are widely used today in image processing, speech recognition, language translation, and in many intelligent applications. Next, let we look about the simplest type of neural networks, that is the feed-forward neural network. It is also called as a single-layer perceptron. So here the information always moves forward from input to the output with no loops. The inputs are multiplied by weights and added to produce a single values. If this value crosses a certain threshold, the network output is 1, otherwise the output is -1. This type of network is mainly used for simple classification problems. When we add more layers, it becomes capable of solving more complex tasks. Okay, next is the learning about the delta rules and gradient descent. So let us understand how the network actually learns. The delta rule compares the predicted output with the actual desired output. If the prediction is wrong, the network adjusts the weight. The weight updation is done using the technique called gradient descent. The gradient descent helps to reduce the error step by step by moving the directions where the loss decreases. So in multi-layer network, this learning process becomes even more efficient in backpropagation. So what is backpropagation? Backpropagation is one of the most important algorithm in deep learning. It works by calculating the errors at output layer and then sending this error backward through the network. Each layer adjusts its weight based on how much error is contributed. So with every training iterations, the total error decreases, which makes the model more accurate. So without backpropagation, deep learning would not be able to possible. And next is we are going to understand how the single neuron works. The neuron performs a weighted sum of inputs similar to the linear regression. It passes the result through an activation function. The activation function adds a non-linearity which helps the network learn complex patterns. Some of the common activation functions are sigmoid, ReLU, and Tannage functions. So each neuron has its own weight factor or weight vectors which keeps getting updated during training. Finally, applications of deep neural network. The deep neural networks are used everywhere today. Some important applications include image and video recognition, like facial recognition in mobile phones, and natural language processing, which includes chatbots, translation, and sentimental analysis, and autonomous systems like self-driving cars, and healthcare for diagnosing the diseases and analyzing the medical images, and financial forecasting for predicting the stocks trends and the risk. So deep learning is transforming the industries, and understanding DNN is the foundation of deep learning. And that brings us the end of the today's session, that is about deep neural networks. So in the next video, we'll explore the deep architectures and more advanced learning techniques in deep learning. Thank you.